Hey everyone! In this tutorial, I'll show you how to use the dd command to erase and format a disk. For this demonstration, I'm using Kali Linux and a USB drive. Once you're logged in, open up a terminal. Once you've opened your terminal window, type sudo fdisk-l and press enter. Fdisk is a command line utility designed for managing disk partitions. With it, you can create, delete, or modify partitions on various storage devices. The "-l option, which stands for list, directs fdisk to display all connected disks and their partitions, providing details such as size, partition type, and device name. After you do this, the system will ask for your password. Please type your password and hit enter again. Remember, your password won't show on the screen for security reasons, so just type it and press enter. Now you can see all connected storage devices. SDA is my Kali Linux disk, with partitions SDA1, SDA2, and SDA5. SDA1 and SDA2 are primary. SDA5 is logical, indicating SDA uses MBR partitioning. Here's the disk I'm going to be using. This is the USB drive labeled as SDB. Make sure you know which partition you're using. Otherwise, you could mistakenly delete data from another drive, resulting in data loss. Once you've identified the correct partition, type sudo fdisk/dev/SDB and hit enter. This command lets you manage partitions on the disk. By using fdisk with /dev/SDB, you enter a menu to view, create, delete, or resize partitions on that specific disk. To create a new partition, type N and press enter. Then P for primary. Primary partitions are used for OS installation and direct booting, with MBR disks limited to 4. If more than 4 partitions are needed, an extended partition can be created to hold logical partitions, which store data but cannot directly boot an OS. For this tutorial, I am selecting P for primary and pressing enter. Now it asks for the partition number. I'll leave it as the default, which is number 1, and just press enter. This choice means we're selecting the first of 4 possible primary partitions. Next, you'll be prompted for the first sector. This marks the beginning of our partition on the disk. The tool will automatically suggest the next available space, which I'll accept by pressing enter. Finally, the last sector defines where the partition will end and determines its size. Instead of using the default to fill the remaining space, I'll specify +25m to create a 25 MB partition. When resizing partitions, you can add or remove a specific number of sectors. For example, +100 adds 100 sectors to your partition, increasing its size, while -100 would remove 100 sectors, reducing it. Sectors are the smallest units on a disk, typically 512 bytes each. You can also change the size. These letters K, M, G, T, and P stand for kilobytes, megabytes, gigabytes, terabytes, and petabytes. For instance, +25m adds 25 megabytes to the partition, making it larger, whereas -25m would remove 25 megabytes, making it smaller. This is more intuitive for understanding how much space you're adding or removing. This is the default range shown on screen, where 2048 is the first sector where changes begin, and the default last sector is over 1 million. If you don't specify a size, it defaults to setting the partition to end at this last sector. Press enter to confirm. Hit W, then press enter to save the partition changes to the disk. This update ensures your system recognizes the new partition setup after a restart. Next, I'll format the partition. Type sudo mkfs-t extension 4/dev/sdb1 and press enter. The makefile system command, also known as mkfs. This command is used to create a new Linux file system on a storage device, such as a hard drive partition. The -t option in mkfs lets us choose the type of file system we want to set up. For this tutorial, we'll use ext4, which stands for the 4th extended file system. ext4 provides many improvements over older file systems, making it a reliable and efficient choice. Now, let's create a directory named USB and prepare to mount the USB drive. Start by typing the following command. Then, hit enter to run the command. Here's what each part of the command does. mkdir or make directory is used to create a new directory or folder in the file system. The directory /mnt, pronounced mount, is a standard location in Linux for manually mounting devices. /USB is the name of the directory where your USB drive will be mounted. This command sets up a mount point, allowing your USB drive to be integrated with the system. After setting up the mount point, let's mount the USB drive. Use this command, then press Enter. Here's what each part does. The mount command makes the file system on the device accessible within the Linux directory structure. /dev/sdb1 represents the partition we created earlier on the second drive, labeled SDB. /mnt/USB is the directory where the USB drive's contents will be accessible. Alright, now that we've mounted our USB drive, let's create a new directory on it. Type this command, then hit Enter. Let's break down what each part of this command does. mkdir, which we mentioned earlier, creates a new directory. /mnt/USB is where we mounted our USB drive, making its contents accessible. Dataval is the name we're choosing for our new directory inside /mnt/USB. By running this command, we're adding a folder called Dataval to our USB drive, perfect for organizing your data. Next, we'll create some sample text files inside our new Dataval directory. Use this command, then hit Enter. Here's an explanation of each component. Touch is a Unix command used to create an empty file or update the timestamp of an existing file. This directory is where we made our folder on the USB. This part uses brace expansion to create 3 files, Files 1, Files 2, and Files 3. With this command, you'll have 3 new empty text files in the Dataval folder on your USB, ready for use or editing. Type this command and hit Enter. This is the ls command from the beginning of the video, used in conjunction with this directory to show the 3 text files we created in the Dataval folder. Before using the dd command, we need to unmount the partition to prevent data corruption and ensure the command works safely. To do this, we'll run the unmount command. Unmounting removes the connection between the partition, like our USB drive, and the system's directory structure. Once unmounted, the system won't be able to read or write to the partition, making it safe for the dd command to write directly to the device without interference. Skipping this step could lead to corrupted data or incomplete writes, so it's an important step for keeping your data intact. Now we're going to use the dd command, which stands for Data Duplicator, to write random data to our partition. This command is a powerful tool for copying and converting data. For example, running this command will write 25 megabytes of random data to the partition. Here's a breakdown of the command. The IF stands for input file. In this case, /dev/urandom is the source of the data, providing a stream of random bytes. The OF stands for output file, and /dev/sdb1 is the destination, the partition we're writing the data to. BS equals 1M. The BS stands for block size, and 1M sets the size of each block that dd will write to the partition. Here, it's set to 1 megabyte, so dd will write 1 megabyte at a time before moving on to the next block. This can affect performance. Larger block sizes typically lead to faster writes. This process is useful for securely erasing old data or testing the drive's write speed. If speed is more important than security, you can replace /dev/urandom with /dev/0. The dd command will then write zeros instead of random data. Using /dev/0 is much faster because generating zeros requires far less processing power than creating random data. However, it is less secure for erasing data, as zeros are easier to recover using forensic tools compared to random data. Choose /dev/urandom when security is the priority, and use /dev/0 if you're only concerned with speed or testing. Adding the status equals progress to the command, this option gives real-time feedback, showing how much data has been transferred and estimating the remaining time, making long operations more manageable. As you can see from the terminal output, the operation took about 7 seconds with a speed of 4 megabytes per second. And that concludes our tutorial on how to wipe a USB drive using the dd command. Remember, this method is effective for securely erasing data or for performance testing, but always ensure you've backed up any important data before proceeding. Thank you for watching, and until next time, stay curious and keep learning.